How are the SSL certificates used at Line managed? We are here to introduce to you the certificate management method, system, and technical background used at Line. Hello everyone. My name is Hwee and I'm in charge of container security technology and certificate management in the Infra Protection 1 team. The main topic for today is the SSL certificate. Certificates are difficult and complex. Generally, when someone is applying for a certificate, this is what they are thinking about. What is a cipher suite? For settings, do I just put in anything in Google? Technology advances fast, but there are so many things to learn and we are busy and there are so many things to consider and everything has to be secured. So I'm going to talk about why managing certificates matter, how the way of managing certificates changed, how the management system is made, and to finish off, I will talk about how you can manage this very difficult and complex certificate management without getting stressed. Most of the internet is the web, and the standard protocol used to manage the communication interval between web is HTTPS. In order to build HTTPS, we use what is called either SSL or TLS certificates. The certificate is said to be used for HTTPS, so why do we use it, and what is it used for, and why is it important to manage this well? Largely, there are two goals for providing HTTPS using SSL certificates. One is to prove that the server the user is connecting to is the correct server through the certificate, and the other is to encrypt the information going to and from the server and thereby securing it. The user agent, which is usually represented by a web browser, uses the SSL certificates of a server to encrypt the communication interval. Then how is the SSL certificate used in this process generated? A service provider like Line generates the data needed to issue a certificate and sends it to the certificate authority, or the CA, an agency in charge of issuing certificates. The CA uses the personal key of the root certificate it has to generate certificate data and encrypts it. This process where a certificate is created and using a root certificate to verify its validity is called signing. The certificate package contains the public key and personal key among other things, and it is used in HTTPS communication once it is installed in the server. When a user accesses the server sends a public key and a certificate to the user. For asymmetrically encrypted communication, the two sides must have different keys from one another. The web browser already has many CA certificates saved in the trusted certificate list. Through the public key included in the certificate passed by the server is verified to check the trustability of the server. Then through OCSP, through a process of checking the existence of a rejected certificate, whether a user has been connected to a server that provides the actual service can be checked. Using the public key included in the certificate passed on from the server, a private key is generated and passed on to the server. Using the shared private key, the web browser and the server can achieve the goal of encrypting the communication interval between the user and the server. It would be great if this process always worked without any problems, right? But that is not the case in reality. Sometimes, and I mean very rarely, accidents happen, such as when the private key of the CA in charge of issuing the certificate is leaked. As a real-life case, in July of 2011, the certification agency Diginota suffered a security breach, and during the investigation process, numerous fake SSL certificates were found. As a result, many browsers registered the certificate as an untrustable certificate, and many companies had to change their certificates, and the certifying agency went bankrupt. The leakage of a server's private key can also lead to a big security breach. The PKI uses the public key and the private key to encrypt and decrypt. For if a server's private key leaks, this means that it could lead to a problematic situation where a cracker can deceive the users, like these, there exist many security threats in the process of using SSL certificates. And in order to stop these accidents from happening, we need to make many efforts, including using a cipher suite with a high level of security and keeping the server-side private key safe. The technology and standard related to SSL certificates are continuously changing and evolving. The hottest topic in 2020 was the shortening the validity period of the certificates. It was about how all of the issued certificates should not have a validity period of more than a year, and major internet technology companies such as Apple and Google have already adopted this policy. Next to the question, can I get a SSL certificate issued for free? Many people talk about Let's Encrypt. Because it is easy to automate, convenient, and provides an industry and business standard level of security, Let's Encrypt is receiving nearly 2 million applications for certificate a day, and its use is rapidly increasing. Until now, the general view was that security and performance work proportionally to one another, but performance-enhanced TLS 1.3, also known as Zero-RTT, actively uses the CDSA algorithm, and at the same time proves that both security and performance issues can be solved at the same time. Line is researching the continuously changing SSL certificate technology, finding ways to actively apply the changes in the market to Line's infrastructure, and consistently improving. The number of servers used by Line is greatly increasing every year due to the continuous growth of its messenger service and release of various new services. As of July 2020, Line has over 50,000 physical servers, 67,000 virtual servers, and the number is growing. In proportion to the increasing number of servers, the demand for SSL certificates also grows. As a result, the management of the certificate also becomes more complex. Certificates are located at the front line of where the service provided by the company and its users meet. Line certificate management system, the Voyager, is a channel that facilitates the use of certificates, and at the same time, it's a system that securely manages certificates. We are making the system so that if there is a certificate-related accident, we can quickly find and check the affected areas to minimize the damages. Now, Seungheun Nim of Line Service Engineering Team will lead the presentation. Hello, I'm Seungheun No, and I'm in charge of the tasks related to Traffic and Service Engineering Team. Up to this point, you have been introduced to the technical environment surrounding the SSL certificate and the real-life challenges. To solve these problems, Voyager is making the necessary things from the bottom up. In this part, we're going to look at what the Voyager team changed to make Line engineers think certificate equals Voyager and what the team achieved. Working in a traffic-related position, I frequently see engineering departments experiencing difficulties in securing SSL certificates. Sometimes it's because the certificate application process guideline on the wiki becomes fragmented or has not been updated. And I often saw engineers getting certificates from their fellow workers because the application process is too complicated and cumbersome. So the first task for Voyager was to improve the complex certificate access permission acquisition process. Before Voyager was implemented, the only channel was to submit a workflow and receive an approval. The applicant had no way of knowing the current status of the certificates held by the company, and verifying the information entered into the workflow was also very difficult for the managers. Therefore, much communication was required in separate channels, which delayed the issuing of certificates. When the workflow is finally approved, the engineer is granted the permission to access the internal wiki storing the requested certificate. Because wiki and the workflow is a separate process, some manual work was needed, and so extra time was needed until a permission was granted, and frequently there were settings errors which made everything very inconvenient. Once the permission was granted, the engineer could finally access the wiki page and could download the certificate file, but an unchanging password was used for the certificate compressed file, and managing the history of downloaded files was also very difficult and was also a security risk. And the access permission to the wiki being permanently alive was also a security risk. There was a general consensus that there is a need for a certificate management system to improve on these inconveniences and weaknesses. So first, through market research, we checked out the commercial solutions that professionally manage certificates. The commercial solutions provided many features, and its level of completeness was very high that it could be applied right away, but we wondered if any of these solutions were the best thing for Line. We first thought about whether a function can be easily added to the system. Can changes be made? Can we scale out according to the user's requests? And because it had to be integrated with many of the internal systems, we looked at whether it is easy to develop the interlocking with internal system and prepare for integration. And given the characteristic of SSL certificate that urgent situations often occur, is a fast response or bypass of the situation possible? Considering these factors, we decided that it would be better in the long run to develop an in-house system. Starting with the LDAP SSO integration, the Voyager started to build a user-centric certificate management system. What was divided into workflow and wiki was combined into the Voyager UI. Now all the necessary information could be validated in a single UI, and we were also able to reflect the DNS check procedure requested by the security team. Afterwards, by automating the creation of workflow, we were able to improve the user experience. The certificate requested by the user is registered in My Certificate list in the Voyager, so now users can easily view granted permissions and current statuses of certificates. Now, it has become easier to respond to events such as expirations and renewals of certificates. We only allow access to certifications to the verified people who already have a permission of access. Also, we began to provide a procedure where the administrator can easily take back this permission. When a user downloads a certificate, a one-time password that is dynamically generated each time, which raises the security level, and also limited, we were able to use the Voyager API for a partial automation. After the establishment of the Voyager, security managers could secure the most updated status of certificate usage, and users returned unnecessary permissions, which enhanced the level of security in certificate use. And of course, the relative parties became more responsible. When the procedure was divided up into workflow and wiki, getting fast access to certificates was very difficult. After being integrated into a single UI, from prior verification to certificate deployment, all the procedures have become simplified. We were able to obtain an improved user scenario and was able to save time that goes into certificate acquisition. Until now, after certificates were issued, the issued certificates were managed in the gray area. By building an integrated DB, service domain certificates and users can now be consistently managed. By managing the lifecycle of the certificates in this way, we can now actively respond to failures that could be caused by expirations of certificates. Line uses an internal cloud platform called the Verda. The software load balancer provided by Verda enables the use of SSL offloading when used in the proxy mode. In this case, the certificate used by the load balancer is also managed by the Voyager, and engineers can secure an environment where they can focus on developing without worrying about the certificates. Of course, according to the service and application characteristics, many times DSR mode is used for load balancing. In this case, the server is in charge of handling the SSL sessions, and each server must have certificates, and this becomes a management burden. In order to reduce some of the tasks, currently a low level of automation is provided through the Voyager API. And in the future, through the Voyager agent, we are trying to provide a system that can be managed more easily. When it is needed, engineers have to not only use physical servers, but also virtual servers and container technology to develop services. Even the frequently created and destroyed resources use SSL certificates, so we need to provide an easy way to manage the certificates. Using Voyager Scanner, the Voyager consistently searches the resources in use and carries out a security check regarding the SSL certificate used by each resource. Whether a certificate has expired or vulnerable cipher suite is used is checked, and also, in order to quantify the level of security, the scoring system is implemented enhanced monitoring. With all the certificate-related tasks being converged into Voyager, the management of security of Voyager has also become an important task. To secure a systematic security structure, the Voyager system is operated in a secured zone, which can only be accessed by a limited number of people. The certificates are encrypted using KMS and stored in the database and are decrypted in memory only when it is requested. And because permission management is performed for each user, unnecessary exposure of information is minimized. And a one-time use passcode is issued each time a certificate is downloaded. To make sure that certificate is not leaked in the development process, we implemented the development management system using TestCA, and this is how the Voyager development tasks are managed. How are useful systems made? A system that users feel is easy to use and is also convenient to use. I think the secret to creating a useful system is that people who directly use the functions provided by the system and have to operate it create the system. Voyager is developed and operated by those people. In general, because SSL certificates have to do with security, people think that it will be managed by the security team, but Voyager is not developed only by the liners and the security organization. Voyager is being developed by engineers from diverse organizations, including organizations in charge of issuing, purchasing, and managing certificates, infrastructure organizations such as Verda, and more. Composed of team members from different organizations right from the planning phase, the advantage of a system made by engineers from relevant department working with certificates as the common denominator is that they create the function that is actually needed. In this process, the role of each member changes sometimes. A security engineer may improve the UI, and a purchase operation team member makes suggestions for simplifying the certificate issuing procedure. While developing the necessary functions, each member provides consultation and feedback based on their expertise in order to create a useful and realistic function which the makers will use most actively. The virtual team in charge of developing and operating the Voyager is one team, and despite the differences in their technical backgrounds and roles, the members build trust in each area of expertise and collaborate across nationalities and locations. Then, what is the ultimate goal of the Voyager? It is ensuring security without giving any stress to the users. It's actually quite tricky for engineers to manage and use the SSL certificates. They only do it once a year, so there is a lack of familiarity, while being concerned about a mistake they could make that could cause a failure in the service. This concern will grow if the number of servers they have to manage are in the tens and hundreds. The stress the engineers feel in this process is greater than we can imagine, especially for an engineer who has experienced a certificate-related failure. So Voyager is aiming to automate all processes. Through automation tools such as Voyager Agent, we are working to reduce the stress related to certificate management and also reducing the potential failures in management and operation. Ultimately, by automating the entire process starting from the user's fingertips, including application to use, purchase, and deploy certificates, the Voyager team's aim is to save time and cost while removing security risk and failure causing variables so that line engineers can focus on development without stressing about certificate-related issues. Like the journey of the probe Voyager traveling along the solar system lines, Voyager has only begun its journey. We're drawing the Voyager system as a traveler who continues on to explore the unknown world. Thank you for listening.